Hello and welcome to the channel Understanding.Concepts.Of.Physics. So here we are today with another numerical on thermodynamics. We have been doing oscillations if you have been following my videos regularly, but this one of the numericals was pending from since some time. So let's just complete this numerical and let's go back to our topics of oscillation. So the question is in front of you. You can just pause the video and go through the question. I'll just highlight the important markers. It's a VT graph, so if you can see there is a the volume and temperature, and in one cycle of this hypothetical heat engine which uses ideal gas, so we are supposed to draw PV graph and PT graph, and the process goes like from A to B, B to C, C to D and D to A. So note that this is a straight line, this is a straight line, but it has some slope. However, this is also straight line, this is also straight line. So these two processes will be isothermal process, and this will also be isothermal process. Now AB and CD will be a process which will be something else. Now definitely it is not isochoric, this is not isochoric, this is not isothermal as well. So it could be adiabatic process or it could be an isobaric process. Let's see. So we are given a graph and we are supposed to draw PV and PT graph. Let's solve this question. Now what does the AB graph represent? So AB graph represents that the volume is increasing because the graph is going up, the volume is increasing, and because the graph is going to the right, the temperature is also increasing. So volume is increasing and the temperature is also increasing. So that is what it is written. Volume increases, temperature increases. Also you should note that PV is equal to nRT because it's an ideal gas equation, and because our graph is velocity, volume and temperature, volume is equal to this P comes within the denominator, so it will be P, N, R and T in the numerator. Now if I compare this equation with y is equal to mx plus c, now you'll say, okay, why am I comparing this with y is equal to mx plus c? Because my graph is a straight line, and because since my graph is a straight line, I can compare this with y is equal to mx plus c, which is the equation of a straight line. So I'm going to compare this equation with this. So in place of y we have v, that is volume. In place of x we have something called as temperature, because temperature is changing, volume is changing, temperature is changing. So y and x are variable, here is volume and temperature are variable. Regarding n, r and p, we can say that n and r are constant, but we cannot say anything about p as of now. But we know that m is nothing but the slope, and slope is constant for a straight line. It is a constant for a straight line because my graph is a straight line, the slope is constant. So m, if you compare this equation, this part becomes my slope, and because there is no c, plus c is 0, so my slope is m is equal to nr by p. Now because my slope is constant, n is constant, r is also constant, so p will also remain constant, because if you have 3 constants, then multiplying or dividing that 3 constants will give you another constant. So pressure is a constant. So I can say that in this the volume is increasing, the temperature is increasing, however the pressure is constant. This process is isobaric process. And similarly you can go back for this as well. If you see this graph, the volume is decreasing, the temperature is decreasing, the volume is also decreasing, temperature is also decreasing, and it is very much similar to the AB graph. The CD graph is very similar to AB graph. So here also the process would be isobaric process, the pressure would remain constant. So I just mentioned about AB process. The conclusion says the volume is increasing, the temperature is increasing, the pressure is constant. It's an isobaric process. And I also mentioned about the process CD, wherein the volume is decreasing, the temperature is decreasing, PV is equal to nRT is the ideal gas equation, and I have replaced this P from here to the other side. Again y is equal to mx plus c, m is a slope, because it's a straight line, slope is a constant, and so P would remain constant, and this I'll get in the CD process, that is volume is decreasing, temperature is decreasing, pressure is constant, the process is isobaric. Now we come to the BC and the DA process. Now in BC, if you see, the temperature remains constant. So if the graph is very much vertical, the temperature is not changing, even if it is at B, or even if it is C or any intermediate states, the temperature is constant. However, if you see, the volume earlier was large and now the volume is less, so the volume is decreasing, the temperature is constant. So it's an isothermal process. This would be a piece of cake. So volume decreasing, temperature constant. So what we can say about the pressure? So again, ideal gas equation says PV is equal to nRT. So pressure is equal to nRT by V. V is on the other side. Now you can see that N is a constant, R is a constant, and T, temperature, is also a constant, because we see from the graph. So pressure is inversely proportional to V, and when you see a graph which is like P is constant upon V, the graph will not remain a straight line, it will be a curve. It would be a decreasing curve. And this would be an isothermal process, and as you know, PV graph for isothermal process is always a curve. Okay. So if you have got what BC is, DA is also a straight line. This is also, the temperature is constant, so temperature will remain constant. The volume is increasing as it is going from a lower volume to a higher volume, and so the pressure would decrease, because pressure is inversely proportional to volume, in this case if N and R and T are constants. So I have discussed all 4 cases. The 4th case I have just not shown you. In DA, the volume increases, the temperature remains constant, PV is equal to nRT says PV is equal to nRT by V. Because nRT is a constant, pressure is inversely proportional to V. So if volume is increasing, the pressure has to decrease, and it will decrease in a curved manner because it's an inverse relationship. So this is also an isothermal process. We have discussed all the 4 processes. AB is a process in which it's isobaric, BC is isothermal, CD is isobaric, and DA is isothermal. Now let's just quickly plot the graphs. First is PV graph. So I have a P on the y-axis and V on the x-axis, 0 at the origin. Now just see where the A point is. The point A is at here, and the process AB, as we have discussed earlier, the process AB is an isobaric process. So the pressure will remain constant and the volume is increasing. That's why the graph is moving ahead, because right side the volume increases, left side the volume decreases. Going up is pressure increases, coming down is pressure decreases. So I get this graph because it's an isobaric process, and it's an expansion because the volume is increasing. Now at point B, the graph could have gone anywhere, but you should always go for it's an isothermal process, so it will be a curve first and foremost. Second, they have said the volume is decreasing, so volume decreasing, so volume goes back, and the pressure is increasing. So if you see BC graph, volume is decreasing, pressure is increasing. That's why the graph is going up, and it's a curve because it's an isothermal process. Then coming to CD, what has happened is the pressure remains constant, but the volume is decreasing. So volume is decreasing, so it is going from C to D. And then lastly, isothermal process. It will be a curve, and secondly, the volume is increasing. So earlier the volume was low, and now the volume is high. So volume is increasing, but the pressure is decreasing. So this will be a curve, and also the curve would be in this manner. So this is what the PV graph for the given VT graph is. Now there is one more graph they have asked us for, that is PT graph. So for PT graph, again you should watch only where point A is. Now A, starting with A, they have said that it's an isobaric process, so the pressure remains constant. Then they have said it's an isothermal process, so temperature remains constant. Then they have said it's an isobaric process, so its pressure remains constant. And lastly, their isothermal process, so temperature remains constant. So if the line is horizontal or vertical, that means there has to be something which is constant. So if it is a vertical line, it's an isothermal process. If it's a horizontal line, it's an isobaric process. Definitely, when we are talking about PT graph. So it's an isobaric expansion in this case, isothermal compression in this case, because volume is not seen over here, but you know that we had shown it's an isothermal compression. Then isobaric compression and isothermal expansion. So this is the way how we do it. Now one more thing I would like to highlight, while I was drawing, I figured out whenever you are supposed to plot a graph of P or V or T or any graph, always start from the middle point and then just move on wherever you want to. Now the problem with this is if you start from the beginning, like if you start from here and suppose the graph comes behind something like this, then you are going to the negative territory. So in order to avoid this situation, always start the graph from the center, let's say somewhere around here. Then if the graph comes behind, you have room to play over here, or even if the graph goes on the positive side, something like this, then you can still have room to play. So that's what this numerical was. This is a numerical which was pending on my side, so I've just completed that. Subscribe the channel in case you have not done so up till now. Keep following the videos, keep watching the oscillations. I'll be posting newer videos on oscillations in the coming videos. Thank you so much. Have a nice day. Bye.